This is some of the boats he built, racing the regattas, one like that. Go through this fairly fast. He loved to fish. This is Lake Saranac, about 1950, upstate New York. And another shot of him as a fisherman, aging. The photo not in very good shape. And an unidentified member of the family, I'm still trying to find out who it is, who is known to be a family member, but father was not on that trip. That's about all I can determine. And this picture was taken, we're not sure exactly when. Could have been taken in the 40s, could have been taken in the early 50s. Most likely in the 50s. He had other ships and interests, fishing fleets, shrimpers, and such, and deep sea fishing was a main hobby. These were some of his awards. Father in the middle, the man on the left we don't know, the man on the right was the vice president of Morgan Guarantee and Trust Company. So father traveled in very interesting circles. This was the family seat in the East Islip. It is still there. West Islip, I'm sorry. And it is still there. It was built in 1906. And we were raised there. Auntie kept it under the family name until sometime around 1940 or a little later. It was a 23-room mansion. She fell off her horse, broke her leg, was nursed back into health by a Jesuit priest and some nurses. And she got religion, as the saying goes, and donated her fortune in the house to the Catholic Church. The church later sold the house off to private interests who continue to hold it. It's been cut up into 6 apartments, but they maintain it because it is a landmark so officially listed by the town of East Islip. Well, East Islip, West Islip, this plaque is in the hallway as to who it is listed by. I think it's just Islip. Right. Another view of this house, very extensive, huge grounds. Now, Duncan at approximately the age of 8. Notice the lighter colored hair, slightly reddish, approximately age of 10. This was the early Duncan with a surrogate soul before the age of 12. And this is Duncan at about age 16 in Florida, the Florida house that father maintained at that time. Change in personality, the hair still reddish, very fun-loving, impish. This was the private school he graduated from, Marblewood in Connecticut. He was a 4th from the right. He somehow managed to get through. We only found out very recently that Marblewood is an NSA training school. Now it raises some very serious questions. What was he doing in an NSA training school, and how much does his mother really know? She sent him there, that's correct. After he graduated with father down in Florida, and now we know why father almost always wore a hat, almost totally bald. And that was before he enlisted in the Air Force, and his hair turned dark. He went in the Air Force in 1968, was there until about 72. He served in Vietnam. Long story I won't go into. Eventually wound up as part of the Montauk Project, and eventually I relocated him. In, of course, the period around 1985 at the USPA. In 1981, father died, and this picture was taken of Duncan in the period around 1981-82. He had a little money. He acquired the beach house, bought a catamaran, but if you look at him closely, there's a vast change in the personality, and I have other pictures of him I won't even show. They are so dark and show such a darkened personality that really the vibes are grossly negative. You don't want to see them. And that showed on him at that time. The project ended. He was debriefed. He met Preston early on in '84. And things changed then. And then, of course, I met him. And then this picture was taken of Duncan. Looks much like he is today in '86 doing carpentry work, his current trade, from about '84 on. And working on Preston's father's house. 1989 at a U.S., let's see, that was a local Long Island UFO chapter meeting. USPA? That was Psychotronics? I thought that was no, this was not taken in the store. This was taken at the meeting put on by John Ford. I remember now, that was... No, whatever. Yeah, The paneling was there, but it was like that at the other one, too. Anyway, 1989, that was Duncan. I don't know the next man. The one on next to the left we know today is Frank Valenti. He's a friend of all of us. 1990, taken at the Whole Life Expo in New York, October, where Preston and Duncan were attempting to sell some electronics hardware. Very little change in his appearance during this period. Now, what happened to the rest of my family? It's a difficult story. I've never really connected with them. But nevertheless, in the early period of 1960, I bought property in New Mexico, subscribed to this magazine entitled New Mexico Review, and the August 65 issue arrived, turned over the page, and I see this picture advertising what happened the year before in 64 for the New Mexico State Fair, and saying, well, come to the State Fair this year, and similar activities. Cattle judging contest. The man second from the left immediately drew my attention, the one that's kneeling. Didn't know who he was, but I was almost agitated by the picture. I had to go to the New Mexico State Fair, which I did in 65, to try and see if he'd be there. He was not. I asked a lot of questions of the Fair Commission. They couldn't tell me who he was or wouldn't. And I said, well, who were the contestants? We can't tell you. Well, who won the contest? Well, we can tell you that, but we'll send you the list and mail it to me. I never did receive it. Well, who did the picture? Well, they told me who, and I went and got an 8x10 glossy and eventually blew it up. And this was a blow-up of that picture. This is the picture I showed to Preston just before he went to Deerfield, New Hampshire in October, the first October weekend in 1990. And, of course, that was taken in 1964. And I have reason to believe that was Jeff, because his life has been in agriculture. I found that out. And there was an accident that thing survived. Nobody knew who he was, and he was never identified. And many people since, many good psychics, have asked them, is there anybody in this picture, showing them, of course, the larger picture, that might have any connection with me? And they all point at the same individual. Made several attempts to meet with him. I never have. Preston says, yeah, look like the same guy, but much older. 47 now, I guess he would. All right, let's hold this slide, and now let's get into the theory. I'm going to shut the slide projector off for a moment. We'll come back to this one. Just shut the light off. We'll leave the fan on. If you don't leave the fan on, it'll burn the bulb out. Put some lights on. Now, what were we attempting to do on the Eldridge? One of the first things we learned when we went to school in 1940 with von Neumann was that we're not living in a three-dimensional universe, we're living in a five-dimensional universe. The three physical dimensions that we know, plus the fourth dimension, which of course has been fairly well defined by everybody from P.D. Ouspensky in 1931 and Tertium Organum to Einstein, to others, as being time. But it's not as simple as that. I was about to say we have no chalk, but we do. Let's draw a little diagram. I would like to have these in my slides, but I haven't been able to get them made up in slides yet. Let's say that this represents the three dimensions of our reality as we know them. We'll just call them D1, D2, D3, all at right angles to each other. Everything in this room, etc., everything we know, solid three-dimensional structure. But there's an interesting point about this. These things have endurance in time. If there was no time flow, nothing would exist. They are dependent upon a higher dimensionality to exist, and that higher dimensionality is time. So we'll draw it as a dotted line with an arrow on it, indicating there is a flow, and we can call it, for convenience, T1. It is, in a certain sense, at right angles to the other three, but that is not a true relationship. It is a flow of time, and I'll get back to that drawing up or slide to explain it further. But T1, or the fourth dimension, is not the only dimension that's involved. There's a secondary dimension called T2, or a spinner. And this thing is really a vector which rotates at right angles on T1. In other words, if I were to use this pointer to represent T1 or the fourth dimension, you have T2 or spinner as a vector at right angles rotating around the end. But it's doing more than that. It is T2 that really is the control function, because this thing is traveling as a helix, if you want to draw it that way mathematically. And as it rotates in this manner, it is doing a corkscrew number through the universe, and that corkscrew number, the forward motion, the average time of this other vector, which I drew here, is time as we measure it. We do not measure the spinner. We only measure T1. And that T1 under all normal circumstances is a constant. It can be altered. And that's what we were working on. What were we trying to do with the Philadelphia experiment? We were trying to change the position in the time stream of the ship sufficiently with electromagnetic means that the energy which would come from a radar signal or from light would pass straight through so far as anybody could tell or see. There would be no reflection. And if there is no reflection of any energy, light energy, radar energy, or whatever, you have no image. Everything you see or I see or a radar display screen sees is dependent upon reflected energy. If there's no reflection, you don't see anything, regardless of whether it's there or not. And that was the basis for producing the invisibility field. Now I'll go back briefly to the slide. If you want to turn the light back on, and the light's out, we'll cover this slide, then we'll go on from there. In a book entitled How You May Explore Higher Dimensions of Time and Space by P.D. Bielek is the man, published 1989. He has a number of different drawings, but this one, the so-called Torus of Time, is perhaps the best and the most explanatory. How You May Explore Higher Dimensions of Space and Time by T.B. Bielek. I have it there. In fact, it's sitting under the slide tray, I think, or under the slide projector. Now, as he shows it here, and it's mathematically quite correct, you have a torus formed by time, because time is not open-ended. It is a closed loop, so far as we can tell. And this is what Einstein said, among other things. He said there is no such thing as a straight line in our universe. If you think you have a straight line and you could send a straight line out, let's say from your chest, and you went long enough and far enough, you'd wind up hitting yourself in the back. Of course, this is speaking theoretically, and also it is correct in the sense that it is a curved, closed universe. And this also applies to time. But this corkscrew spinner generates the timeline, which we reference, but it also does something else. It generates the normal reality which we know as we exist in. But there are alternate realities. If you go 90 degrees around this torus, you will have another reality, an alternate one, very similar to ours. Many things, most things will be the same. There might be a few people missing, there might be a few additional people, a building or two might be different, but it'll appear to be exactly the same as ours because it's locked in the same time stream, but it's phase shifted by 90 degrees. Now, if you take an object, such as a warship, if you were to take it 90 degrees, it would be in another universe, so to speak, another reality. If you take it part way around, like about 60 degrees, it becomes invisible, but it is still physically there. You can go up and hit it. So that was what basically we were doing at that time. Now, of course, invisibility has seen a few improvements and a few changes. That was the basic business, and you can have a number of alternate realities. You can also have split-offs from the main line to still other realities, and you can even go into other universes. This gets into deep theory I don't want to get into. And for that matter, I don't even know most of it. It's very involved and very abstruse. But I thought you'd like to see this because this represents quite well what Einstein said in his unified field theory. It's a closed universe on a closed circuit. Preston on Friday gave more information in terms of the time sea and how the time function actually works. Yes. So let's have the lights back on and the slide projector off, and then we'll go on from there. So we still have quite a bit to cover. let's give a little plan drawing of the Eldridge. I'm not the world's greatest artist, like Preston. I guess I know. Neither of us are. Let's draw this sort of like this. That will represent the bow, and this will represent the stern of the Eldridge. Here, someplace in the middle, we had this antenna, we had this square room. We'll leave a lot off. We have gun turrets and so forth. We have this big antenna right here in the middle. But we have 4 coils designed by Tesla and used also by von Neumann with very little change other than he put a damping coil on the top, because when you go from a CW type analog signal to a pulse signal, these coils would ring like a banshee. 2 in front, 2 in back. These are gun turrets, so I'll just erase them. They may be confusing to you. The antenna in the center was a quadrophase antenna, which meant it had 4 phased sections to the array, each independently fed by a radio transmitter. Each transmitter was modulated by its own chain of electronics, which went back to the basic pulse generator, the zero-time reference generator, and so forth. That RF system was locked to, in terms of phase and frequency modulation generation to the pulse generator, to the magnetic system, but was independent otherwise. The magnetic system consisted of 2 huge generators, 275 kVA generators, electronically locked to each other. For reasons which I don't recall now, each had 5 field windings. There were 10 total. Each field winding was driven by a bank of 300 6L6 tubes. So there were 3,000 total. There were buffer drivers for those and so forth. They had to be able to modulate, turn on and turn off the current in the 5 windings. And they did it in a manner such that by pulsing it, they could still create a rotating magnetic field. You would phase these things. There would be, the 4 would be out of phase with each other, the same as here. In other words, you had a relationship basically of 90 degrees between each one for the RF and between the magnetic. They overlapped, but they did it even in spite of the fact they were pulsed.
So vertically oriented, so north-south poles and
Correct, and that's a good point. They were conical. I was just about to describe that. Each coil stood approximately this high. They were narrow at the top, approximately like so. They tapered in a conical form down to the base, and tapering down to the base conically like that, they broadened out extensively, probably to about 3 feet. They had 2 cable feeds. There was not a Tesla coil in the sense of having a drive at one end only. They had actual solid cable feeds from the generators, and each coil was fed in its own separate amplifier chain, actually from the generator, because they controlled the output of each coil from 2 separate sets of slip rings from the alternators, and the entire field windings controlled the phasing of the entire system because of the drive from the electronics. It was very complex, but they did get what they wanted in terms of the magnetics, so that they phased incorrectly, and you wound up generating a magnetic field around this ship, which became, in essence, a toroid, an open toroid. Now we'll do another drawing for you. The RF fields were generated here within the magnetic field, and the 2 interacted. One was twice the frequency of the other. They were both tied to the famous pi/2 series, which is very basic to such phenomena on Earth. And they were keyed to each other, and they were keyed to other mathematics, which will give you a window. Now, how do we get it? Perhaps many of you don't know, maybe most of you don't know, there's a very strange relationship existing, as was pointed out in the unified field theory, between the E field, or electrostatic field, a G field, or the gravitic or tachyon field, whatever you want to call it, and the H field, or magnetic field. I drew them this way because you can draw them in a different form. This, if you separate out and draw it in a slightly larger scale, with the arrows pointing in, would be again your E, G, and H. The forces will be forcing towards the center. Three interact, and of course they interact with time. And what happens is if you manipulate E and H correctly, you also manipulate G, and if you manipulate the three of them, you then create a time effect. You change the local time. Now, by changing the local time, what do? You're changing the T2 spinner. So within the confines of the field, not outside of it, but within the confines of that field, you are actually changing the time flow rate, slightly. That was the intent. And by changing it slightly, the ship, in terms of the torus of time, goes from its point, normal point here, we'll call it normal, to someplace up here, if you're looking at the edgewise on to the torus, to someplace up here for the ship, somewhere is around 60 degrees. And then what you had to do was maintain the fields in another manner so they would lock at that point and not slip out of our universe, and maintain the invisibility. I'm sorry? Well, if you go too far around, the ship's out of our reality in another. How do they lock it there? By changing again the rate in which the T2 spinner rate internal to the field is reduced down to what it had been in the first place, i.e. you lock at that point. You're not continually increasing the frequency. You don't maintain it at an increased frequency. You're just deriving a phase shift. When you get to the point you want, you restore the normal spinner rate in that local field. Right. That's all done through basically the generators, the main field coils of the generators. It's a very complex system. Of course, it took an enormous amount of power, and they generated very powerful fields, and the personnel, of course, were very badly hit by it. Those down below deck were not. They were shielded by the steel, with the exception of two men who developed a strange intermittent, one not so intermittent problem of invisibility. But those on deck went insane or disappeared totally. I got a little more data on that, too. Okay, that was basically what they were doing. What did the shape of the field look like? This was the big problem. When the initial research was started, theoretical paperwork, they had a choice. They could either develop an open-ended type of toroidal field, which took four simultaneous nonlinear equations, and that structure, looking at it on end, let's say from above, would show a field somewhat like this, much like a donut. And you would have an area in here where the ship was. And of course, if you look at it sideways, you would see first the water. You would see a coil, not a coil structure, but a field structure which would look somewhat like a donut. And you would have radiating out from here, of course, other aspects of the field, because the field was fairly well defined in here. And like any toroidal field, there's some leakage, particularly the way they ran this one. And you would have some part of the field structure above water and some part of the field structure below water. But here's the key point. The magnetic field coils were arranged in such manner, again, I'll draw them like this. You had a cable connection here and a cable connection here. These were on the deck, so they were pointing up. You would have all one field up one end and the other field down the other end. They would maintain the fields, and this is you could do with pulsing it, maintain the field the way you want it. And you wound up with a magnetic field in here, the H field, which was all one polarity above water and the other polarity was below water. That's how they just got a monopolar magnetic field around the ship above water. Below water it was damped out, so it didn't really count that much, except right around the ship, wherein, of course, the water also became invisible. The water didn't go away. It was there. They formed an actual, even though it was a dipolar field, a monopolar field in terms of above water in the ship. And that was part of Tesla's earlier research. There are papers on this, I understand, available now, but I've not had time to go dig them out. So they had the choice between the open-ended field, the toroid, or if they wanted to go to it and they chose not to because it was much more complex, would have been an oblate spheroid type field which was closed. It didn't have a hole in the center. It was completely closed. The ship would have been enclosed in that field and there would have been no possibility of something coming in from the outside and interacting with it. And of course, with this type of an open field, something could interact, and it did. There you had an open-ended toroidal field. The ship was in the middle. The critical date was 12 August 1983, as we found out much later, because on 12 August 1943, 12 August is the critical date, 43, 63, 83, we found this out years later, the Earth has its own biorhythms, like the human body, but there's 4 of them, and they all peak out every 20 years with a nice, sharp, synchronizing peak, 1 day wide, roughly. And that day is the 12th of August. You have to also take into account the slippage of the calendar due to the fact it's a Gregorian calendar, which will say that by the end of the century they have to add another day, so it's already slipped most of a day. So 12 August plus or minus half a day, possibly 1 day. But with that field structure, it was open. It was open to interference. It was open to coupling. So what happened? We'll do a little graph type thing. Here is the Eldridge in graphical form. 1943, 12 August. We'll draw this timeline as a dotted line. Up here we have 1983. We'll show a radar tower with a nice big radar antenna on the top. And this is 1983. And you also have a date in the middle, 1963, 12 August. Here we have the fields around this ship, an open-ended toroid. Here we have this generator out here, which was much more powerful actually than the one down there, generating its own fields, but they were not generated by the radar antenna at that time. They were generated by a set of coils underground, a delta T function coil. On that date, the 12th of August, because on 22 July, this ship was tested and there was no lockup with anything. And we don't know now, unless Preston does from his log books, whether or not the transmitter was on that date, but even if it was on, that is Montauk transmitter, was on the 22nd, there would not have been a lockup. The two turn on that date, you got a coupling. What happens? Strangely enough, this little ship, not very little either, at 1,540 tons, takes off into hyperspace. An artificial structure in many respects, mathematically quite well defined, but in terms of the reality of the universe, it was out of our universe. The Eldridge was literally sucked into hyperspace because of the interaction of the two fields. That thing was very well anchored with a few million tons of earth, soil, concrete, and rock. And this thing was only 1,540 tons, so off it went. It wound up here. It was protected by its own fields from disintegrating, and as long as those fields remained intact, that ship remained intact and the personnel on board remained intact. Now, we couldn't control it. The thing went out of hand. We left the control room. We went outside. We jumped overboard. The ship was someplace up here in hyperspace, undefined time. You can't define time with this hyperspace function. So we jumped overboard, the two of us, and somehow we wound up back here at 83. There were two other people who jumped overboard, and they disintegrated. It was more than luck. It was, one could say, divinely controlled, one could say fate, or one could also add the factor that Duncan and I were already there, and the fact that I, as Al Bielek, was working on the Montauk project from sometime in 53 off and on until 83, and Duncan was there as Duncan number 2. on the project. He was physically there at the site on 12 August 83. I was not physically there on the site on 12 August 83. They told me to take a hike for a couple of days before that date. And Duncan was held elsewhere. But we successfully arrived for whatever reason. Then we were returned to the Eldridge back here. We went on board the ship, took access, smashed the equipment in the Eldridge. Winds up back here in 43 in the harbor about 4 hours later.
How did you go back? What did they do?
They sent us back by means of the time tunnels and the time tunnel operation at Montauk because they had total control over space and time. Speaking in terms of mathematics,
You stepped into something?
we stepped into a hole in the wall, illuminated, which is about 8 feet in diameter, in which we were propelled down that tunnel, if you will, and wound up in the decks of the Eldridge. We didn't fly, obviously, and that ship was in hyperspace, and somehow they knew how to connect with it. Don't ask me how, I have no idea. Now, Van Neumann might be able to tell, but he's not talking very much these days. The first one was quite terrifying. The second one, we knew what was coming, so it didn't bother us. The only thing was, in going back again, we were falling through what appeared to be a tunnel, or seemed like a tunnel, felt very strange. Very much like if you were to jump off the top floor of an elevator shaft when there's no elevator. And you go down, of course you don't hit the floor the way we did it, but that falling sensation, or if you jump out of an airplane with a parachute, that falling sensation you have until the parachute opens or something intercepts your fall. It's the weightlessness, it's about the same. That's a good question. There was air on board the ship. What happened when we left, we don't know. It wasn't that long. You can survive without oxygen for over 2 minutes. It took less. I'd say 1 to 2 minutes. If it was 1 minute, there would be no problem, even for somebody who was not used to holding their breath. I can't explain that physiological aspect directly, because I don't know exactly what happened that way. But 2003, you will have another potential lockup point. Well, I don't think the Eldridge is around with the equipment to do it, but this is still around, and it's operational again. They put it back online in August of 92. January 17th, 93, they had an explosion that put it offline, and then on June 17th, it blew up again. It's currently offline, but we know they're going to put it back online. They're working desperately to get it back online because on the 12th of August of 93, you have an in-between 10-year window point. Now, let me show you just a wee bit more. And then we're going to get into the time business a little more. Okay. Let's draw this as a 20-year period, 43, 63. You have a semi-node point at 53, which is 10 years in between. Or if you call this 83, or rather we'll call that 2003, and call this 83. You have an in-between 10-year point, which in this case would be 93, that's this year, would be on the 12th of August. You have a 5-year semi-node point in which not much occurs, but the in-between one is active, and you can interact. We suspect, we think, we don't know, but we suspect that they want to extend that time tunnel from the year 1983 to 2003 because there is a solid wall in the year 2013 which prevents them from looking beyond it with a time machine, prevents them from doing much of anything. It's to keep this era from interfering with the future era beyond the wall of 2013. I could talk a lot more about that, but it would take much time and revealing certain confidences. But in any case, we know they probably want to extend the wall because they have complained, not to me, but to Preston, they can't view beyond the year roughly 2013 with a time machine. They don't know what's going to happen beyond that. And these world powers, the New World Order people, they're worried. Are we going to be able to extend our power? Are we going to keep operating and controlling everything beyond 2013? They're literally worried. All I can say is tough. Okay, that is really what's going on now with the 93 thing. You have this 10-year in between node point, and that occurs every 10-year point between any of the other dates. Now, let's get into something more on this time business. The manipulation of time and that sort of thing. And at this point, very quickly, I'm going to get pressed in on it. There was a breakthrough, many breakthroughs. One other item I should tell you is when they resurrected the project for the Philadelphia Experiment in 47, And von Neumann was asked to reopen it, see if he could find out what really went wrong, what could be salvaged, if anything. So he reopened it, became involved, as he was then, in many projects, but basically he found that there was a problem that could be surmounted. The basic problem was the human element, not the hardware, in terms of the ship. How do you lock the time references of each individual down, which was established at the time of conception for each individual is born into this time frame, or any time frame, when the body is actually created as a functioning fetus? It has a time lock, and the soul is going to go into that body has a lock on that point in time so that it will be referencing a specific point in history and not floating all over the place. And it goes through the point of process of being born. You live out your life. You know all your friends from every day. You don't slip out of the time stream and go somewhere else. But if you lose those time locks for any reason, and that is what happened to a lot of them on the Eldridge, because of the excessively powerful electromagnetic fields that wrecked their time locks, they started to float in space-time, literally, physically, as well as mentally. But they would float in that time reference, and while they were contained, as long as the fields were intact, when the equipment was destroyed and the Eldridge came back to 43, the fields were collapsing, the control over those individuals was lost, they drifted, some of them wound up in the bulkhead, some disappeared, and others were pulled for another project. We have some follow-on projects. Of course, von Neumann solved the problem. In 1953, they had a totally successful test. It was then reclassified again and called Project Phoenix. Project Phoenix is a coverall for an awful lot of projects. VIR, virtual interpretive reality, for other research projects on mind control, for a number of others. We don't even know all of the projects they did at Montauk. Weather control was part of it, under Phoenix. That started at Brookhaven. Many, many projects. But when they finally solved this, of course, it went through many generations. They finally got the equipment small enough to put on aircraft. Today, it's on all the Navy fighters, all the Israeli fighters, the B-1 bomber, the B-2 bomber, the SR-71, all the large supercarriers. We don't know what else they can put it on, except we know it's down now to a nice little small package that you can put on your belt, flip a switch, and you're invisible. And the Secret Service uses it. And I have photos to prove it. I wouldn't be surprised what was in here in the last 2 days. But this is part of the ongoing research on invisibility, time shifting, time manipulation, time machines. But certain other things occurred in the 50s and the 60s, development of transistors, solid-state devices. And one of the very interesting little devices that was developed was a special germanium transistor known as the SBT, surface barrier transistor. And this one was developed along several parallel pathways. There are at least 5 papers in the journals of the IEEE describing the Philco and Sprague process for producing these things, roughly from about late 1950, I think 58, 59 on. There's a whole series of these papers showing the processing techniques. These were germanium devices before they came into production on silicon. Silicon, a whole new ball game, really. But they have very strange characteristics. And we have found, by accident, by design, whatever, that transistor working in conjunction with another device and a coil can very simply produce a time-modulating field. Now I'm going to draw you a block diagram and then a very rough, crude diagram of the electronics, because it is a very simple device and it's very portable. We'll start with what is basically an oscillator. We then have the transistor. And this one goes to, I think the way it's done right now is -9 volts. This comes out to a coil, which then goes to ground. And of course you have an RC out here to control the frequency. It is one of these special surface barrier transistors specially developed by the government on a special program, which was literally 100% of the product went to the government. And they shut the lines down in 1971 and were told the manufacturer to scrap over 500,000 of these things who didn't scrap them. They got buried. Yeah, this coil is a special 4-pi coil, which we can explain. But what happens when you turn this thing on and when you set a frequency, which is really the oscillating frequency of this 555 square wave output? Without just simplifying this, you switch this device on and off. And because of the way this device works, in conjunction with driving some current through this coil, out of the end of this coil, you produce a delta T field. It is actually time modulating field. Now, Preston, do you want to get into the theory of this thing? Then we will demonstrate it. And I said demonstrate it. That is a little hard to explain. I can't answer that one, really. It remained in hyperspace, and as I remember, some of the other data which has come through since indicates there was more than Eldridge in the hyperspace. There was other hardware seen floating around out there, like some aircraft, a submarine or two, and so forth, which, because of the fact, I did forget to mention, the Germans were working on the same project themselves in World War II. They lost a number of submarines totally to this project, their own version. And we also had 3, not 1 destroyer. We had DE-013, DE-078, and DE-173, which was the Eldridge. I don't know much about the other 2, except they were outfitted in the Philadelphia Navy Yard. I know 2 people who have verified this. And one of them sank in the Azores in its test, and what happened to the 3rd one, I don't know. But why none of them wound up at Montauk? It's a good point. I don't know. Justin, you want to take over?
Okay, before we go into the actual workings of the transistor, let's first go deeper and heavier into the delta T function. What is delta T? Delta, of course, is change. T, of course, is time. Change is modulation. Now, how do we get delta T? This can be yielded from essentially a transform, which is a function of frequency going to a function of time. How do we get this? I'll have to erase the beginning of the antenna here. Let's consider what really this is all about. If we have, let's call this our delta function here. This is yielded from essentially a summation, n equals 0, n equals infinity. This is essentially functions of frequency coupled with time sub 0 crossed by time sub infinity. This, of course, will give you almost an infinite series. It will just keep going on and on and on and on. This series turns out to be holographic. So we could essentially limit this by a bandwidth. What we're doing here is we're taking a frequency transform, crossing it, processing it by a cross of t sub 0, cross of t sub infinity. What is t sub 0? This, of course, is the center of the torus. T sub infinity is the edge of torus. If you remember from my lecture on Friday night, I drew the time torus, the whole time enchilada. I really don't want to go through this because this will take a lot of time to explain once again. So what do we actually end up here with? We'll end up with essentially multiple integrals, 0 to t sub 0, 0 to t sub infinity. This is now a delta t. This is now the function inside here is essentially our frequency transform times t sub 0 cross t sub infinity. Now, we got to put a constant out here. If we don't put a constant out here, this whole thing falls apart. This is going to be another cross with gravitation.
Any move from transcendental ways so that the camera can pay the formulas for the color and motion.
Okay. Now, what we're getting at here, have to excuse me, I'm recalling this all from memory. I did not expect to do this, so I didn't bring a stack of notes like that to try to reduce to something simple. We again have to put this, which is essentially, now we also have to put in delta t, doing backwards.
So it's the T0
D sub t, d sub 0, d sub infinity, and d sub frequency. And we have to also put in here a third integral, which is minus f to plus f, which represents the bandwidth. Remember, we're talking here infinite bandwidth. This is holographic. You can take a limited slice of this bandwidth, and you'll still get the delta t function.
The T0 and T infinity along T1 or T2 dimensions.
No. T0, again, is the center of the time torus. We're on a manifold that goes from the edge to the edge of the time torus. As those spinners, as the twisters rotate in the time torus itself is a closed-end spinner. As those twisters twist, they create tangents, which create manifolds in the edge, in the center, where they all cross multiple manifolds. That T sub is 0. Now, the outer edge of the torus is T sub infinity.
Are you referring to those as vectors then, and the vector product?
Yeah, this is all vectors here. We're doing essentially a scalar vector cross product. Because, okay, yes.
On this integral equation here, should there be another integral for the gravity function?
Yeah, right here. G is an overall integral. That essentially is del cross E cross B I'm not sure if I'm putting this down exactly correct. This is a triple del cross product G. Now you got to put here all this crud for J, omega, epsilon, mu, and the gravitational constant, which is usually little g. You got to add that all on at the end of this. This is equal to what, people? 0, real, and plus or minus I, j, k. I is t sub 0. J is t sub infinity. K is your gravitational constant again. What this is telling us, we have to sum these all things together. We can pick this out. All this drops out. And we get essentially that electric vector crossed to a magnetic vector is through a curl, or the del function, and you curl again to get to the gravitational vector. You got to take this, substitute this up there. This thing keeps growing bigger and bigger. Now, this f sub t, what is this? This is a frequency transform. Now I have to erase the blackboard. Everybody got it before I erase the blackboard. Because I've run out of space.
Tell us again what n and n equals 0 again.
Here? This is the initial summation of your frequency times 0 times infinity, where you're going from the 0 harmonic to the infinite harmonic. This is everything. This is the whole universe. Well, of course, we're limiting the bandwidth. So now we're breaking it up into integrals, where we go from a minus f to a plus f, which is giving us the bandwidth factor, because our systems are not infinite bandwidth. At least not yet. Here, let me put this back.
You guys on the first two rows, dive a little bit under so that you know the last row of the formula.
Maybe what we should do is bring the blackboard up here. Okay, hang on. First, we're going to get rid of this chair. You ready? Yeah. Good.
They get the stand, we'll get the blackboard.
Okay, good.
What is the side of the
Okay, everybody got this?
Do you mean have a cross operation with the J?
Mm-hmm. That G vector, electrogravitation, is very important.
Yes. You don't have a cross indicated in there. Yeah. That's lower equation.
Right here.
No, there's the next one down. The curl equation.
Yeah, you're right. Sorry about that.
What is the O on that top sigma formula, the O after F sub F?
This is a mathematical function.
Another thing, you know, the first floor is weather right domain.
Okay, can I go now? Continue.
Yep.
We now going to go into a little bit of theory on delta pulses. I'll repeat that. I'll repeat it. I only have two hands. Okay, now we got to go into some theory on Dirac delta pulses. What is a delta pulse? You have amplitude in this direction, whether it's voltage, current, whatever, it doesn't matter. You got time this way. You go along, all of a sudden, you get a spike. It goes up, comes down on the same spike. Let's now expand this. It comes out a nice square rectangular pulse. The true Dirac delta pulse, in theory, is pulse width. It's the limit of the delta P is delta pulse. It's the limit of the frequency transform as pulse width goes to 0. Now you're taking this thing and you're shrinking it to 0. What happens, engineers in the audience, when you shrink this pulse width to 0? The bandwidth of the pulse goes to infinity. It starts at the rep rate of the pulse that goes to infinity. Now, consider this. What's the tan? What's the tangent of 0? 0. What's the tangent of 90 degrees? Infinity. So what is this telling us? In the orthorotation world that your tangent represents, because the tangent goes like this, 90-degree rotation is you're going from 0 to infinity. So that means, what this means, if we take our limited bandwidth and generate 2 or more 90-degree functions, we can now take that limited bandwidth and make the pulse appear to be a true Dirac delta pulse. This is how the delta T antenna works. Delta T antenna, to review, of course, is a triple delta loop. And it ends up being the double pyramid shape. X, Y, and Z. What is this thing? A loop this way. A loop this way. A loop this way. We got 3 delta loops, orthogonal, right angles to each other. Now, if you remember, we had our multiple cross products involving electrogravitation, T sub 0, T sub infinity, and our infinite frequency transform with the frequency coefficients from n equals 0 to n equals infinity. We can't do that. We got to go from n equals 0, that's your DC component, to some finite boundary, maybe 20 kilohertz. So now we're going to have an integral equation. 0 here, 20 kc here. Take it every hertz, so it means you got 20,000 steps in your integral for your limits of integration. This is 0 to T sub 0. This is 0 to T sub infinity. Now we're going to put in here our delta of n. This would be n. We're going to put in our frequency, our transform of frequency. We're going to put in our T sub 0, which actually is the tangent of 0. We're going to put in our T sub infinity, which is actually here, tangent of infinity. Yeah. So this has to be tangent of 90. I'm no better than any of your other college instructors. We all make mistakes. I'm not alien, no more than anyone else in this room is alien. Now also, I don't know what the correlating equality is, but we have, I'm going to show it this way, G, your G vector. What I'm saying here is we don't understand the proportionality, but we don't need it to bend time. Now, considering that this is tangent of 0, as long as we have some function that is referenced to tangent of 0, or t sub 0, we can satisfy this. Tangent of infinity, t sub infinity. How do we get t sub infinity? This is something I have grappled with for years. Last night, while trying to sleep in this hellhole, I finally remembered how it was done. Anyone know what white noise is? White noise is a frequency transform with all frequencies in it. It's a group of Dirac delta pulses of different rep rates superimposed to make this broadband. So now, to make this broadband function, we call white noise. White noise is 50% correlated to anything and everything. Our reality is 50% correlated to the entire white noise function. Our reality, if you look at it as the whole enchilada, what do we come out with? It's fractals, right? Fractals. Now, if you take fractals over the entire limit, 0 to infinity, what do you come up with, people? A broadband noise-like function. So any Gaussian type white noise source, which is magnetically focused, since remember the last lecture I gave, we spoke of the magnetic field as being potential field 90 degrees away from us. You have to have a special white noise source which is magnetically focused. Is a T sub infinity reference. So now this is Tesla's whirligig, as I call it. This is white noise.